Welcome everyone. Today's session focuses on the Autumn 24 Chief Examiner Report for the T-Level in Healthcare Science, specifically the core papers A and B. So the focus of this session is to highlight student strengths and weaknesses, examine extended response performance, and identify key teaching implications. Core paper A covered areas such as legislation, health and safety and regulatory frameworks, and core paper B focused on biology, chemistry and physics. As we go through this session, we'll explore what went well, areas for development, key patterns, teaching implication, and data to inform your delivery. Let's begin with key themes for Core A. Paper A showcased solid performance in questions requiring recall, such as identifying PPE and COSH. In question 13, for instance, students not only named items but showed they understood practical considerations. The ERQ, or Extended Response question on safe data storage in question 23, was handled better than others, with students applying some procedural knowledge through evaluation, though evaluation was weaker. It was also encouraging to see confident responses in foundational questions like environments for healthcare scientists in question 2 and equipment calibration in question 24. Despite some positives, challenges persisted in paper A. Question 3 showed students are more familiar with common abuse types, not organisational abuse. And question 10 highlighted a gap in knowledge of key legislation, such as the 2022 PPE regulations. ERQs, especially question 18 on waste policies, suffered from limited application and evaluations. Students tended to offer alternative ideas rather than assessing what was in the scenario. Question 15 revealed confusion over sterilising single-use items. Many students thought these were for reuse, which shows a need to revisit infection control protocols. And again, we are seeing inadequate development of AO2 and 3 in ERQs. This slide presents a visual overview of question level performance in core paper A. Starting with green zone, students showed strong recall and understanding on straightforward knowledge-based items, like question 22 on healthcare science environment, question 9 on COSH regulations, and question 13A and B, which explored PPE identification use. Responses to question 4 concerning equipment calibration also indicated secure understanding. In the amber zone, we begin to see signs of partial understanding and weaker application. For example, in question 20, some students understood how social media might be used in healthcare contexts, but struggled to apply their ideas clearly. Similarly, question 23 respondents often outlined the basics of data security, but fell short in fully evaluating the scenario. Question 28, which covered good laboratory practice, showed some knowledge but limited application or critique. The red zone highlight key areas for development. Questions like 3, 10 and 15 indicate conceptual gaps, particularly around safeguarding and sterilisation methods. ERQs like question 16, 18 and 25 revealed difficulty with evaluations. Students tended to describe or suggest alternatives rather than assess the given scenarios. These patterns help pinpoint where teaching should focus next, especially improving evaluation skills, reinforcing technical terminology, and making legislative knowledge more meaningful through case-based learning. So beginning with the key themes of the paper A, we notice students are confident when answering direct knowledge questions, but once the demand moves into application and evaluation, performance dips. Infection control, for example, is often taught, but not always applied well to scenarios. Similarly, when roles and procedures are unfamiliar, students generalise or guess. This calls for more scenario-driven delivery and exposure to a wider range of professional contexts. To prove outcomes in paper A, here are some key strategies to consider. First, we need to build evaluation skills. AO3 continues to be a weak point. Provide sentence starters like "this is effective because" or "an alternative might be" can help students transition from description to analysis. Second, many students struggled with identifying or applying correct procedures. Use real-life case studies, role-play activities, or short answers to help them understand who does what in a healthcare setting, particularly for infection control and waste management. Thirdly, legislation recall was a hit and miss. Considering using activities such as flashcards or quizzes to drill key regulations like COSH, PPE regulations, and GLP. Regular low-stakes retrieval can strengthen long-term memory. Fourth, embed infection control into practical visual learning instead of treating it as a standalone topic. Simulate scenarios, discuss what went right or wrong, and connect the actions back to legislation. And finally, keep PPE and safety central to everything. Use safety starter tasks and lessons, mini scenarios that ask students to spot hazards or choose the correct PPE for a task. Repetition in varied contexts builds deeper understanding. Now for key themes for Core B. In Paper B, many students showcase promising skills in maths-related tasks. For example, question 1C and 9 revealed a good grasp for using formulas, converting units, and interpreting results. Question 6, which dealt with immune responses and epidemiological reasoning, was handled well by students who could apply and structure their understanding. Students also performed confidently in microbiology questions like question 2A, and some were able to analyse the effectiveness of medical interventions in question 13. Paper B also highlighted several learning gaps. Question 3B and 4A showed uncertainty around disease mechanisms, key content from biology. Question 8 and 11 revealed misconceptions in physics, with many students mixing up radiation types or omitting key MRI safety considerations. Extended responses, particularly questions 10, 14 and 15, often lacked evaluation. Many answers were descriptive or inaccurate, showing a need for more structured critical thinking in science-based ERQs. This visual breakdown highlights performance patterns for Core Paper E, organised by colour to represent high, moderate and low achievement. In the green zone, students performed strongly on calculation questions, such as questions 1C, 2D and 9, demonstrating confidence in rearranging formulas and converting units, though a few still lost marks for rounding or unit errors. Question 2A, which asked about staining techniques, also showed solid understanding, showing this area of microbiology is being delivered effectively. Question 6, the extended response on the immune system and epidemiology, was one of the stronger ERQs in this paper. Students who understood antigen response and transmission patterns applied their knowledge well. Question 13, which involved interpreting a drug trial graph, was also handled well by students who drew logical conclusions about drug effectiveness. In the amber zone, students showed some knowledge but struggled with depth. For example, in question 8B, they showed awareness that steel is magnetic in an MRI room but missed out on the clinical risks. Question 12C revealed partial understanding of atomic structure but lacked a complete link to reactivity. Question 14 on evaluating material properties had some valid points but rarely moved into critical assessment. The red zone includes areas of concern. Question 3B and 4A revealed biological misconceptions about oxygen transport and disease classification. Question 10 and 11, which dealt with food preservation and ionizing radiation, showed confusion, particularly around radiation types and their properties. And finally, question 15, a complex ERQ involving gas chromatography, was often answered superficially, with students struggling to evaluate the scientific claims presented. These performance patterns clearly indicate the need for more contextual teaching of physics and chemistry content and more practice with analytical writing in science contexts. So what were the key themes? Some students can perform calculations well, but lose marks by not rounding or including units. Basic but essential exam skills. Evaluation remains a weak point. Many students simply list facts instead of critiquing a method or conclusion. Knowledge gaps in biology and chemistry indicate that these areas may need to be revisited and taught more contextually. Finally, students often fail to connect abstract science content to real-world healthcare settings, especially when dealing with radiation, reactivity, or gas chromatography. To help succeed in Paper B, strengthen their ability to apply science by connecting abstract content to clinical scenarios. Prioritize math accuracy, especially in presentation of final answers. Scaffold AO3 through structured evaluation activities, modelling and peer comparison. And finally, combat key misconceptions through targeted retrieval and visual teaching strategies. So now for final thoughts, we're going to explore assessment objectives, AO patterns and next steps. When we look across both Paper A and Paper B, clear AO1 trends emerge, particularly in the areas of terminology and recall accuracy. Paper A, many students struggle to recall specific legislation or principles of good laboratory practice. These are terms that may have been covered but not consistently reinforced, and their lower familiarity impacted performance. In Paper B, recall was evident but not always accurate. For example, students misclassed COPD or misunderstood radiation properties, such as stating that gamma radiation has higher ionizing power than alpha, which is incorrect. These issues suggest that while students are engaging with their content, their memory of detail is often shaky or confused. This impacts their ability to access even basic AO2 and AO3 marks, as misunderstandings at AO1 level carry forward into application and evaluation tasks. So what's the implications for teaching? Build in frequent retrieval practice. Use low-stakes quizzes, flashcards, and last lesson recall starters to revisit terminology regularly. Create student-friendly glossaries. Encourage use of teach-back techniques where learners explain concepts in their own words. Use term definition image matching to reinforce learning, especially with abstract or procedural content like GLP or types of radiation. And finally, embed these terms into scenarios so that students move from knowing a definition to recognizing how it functions in practice. This layered approach helps secure AO1 knowledge and sets the foundation for stronger AO2 and AO3 performance. AO2 requires students to apply their knowledge to real-world or exam-based scenarios. Across both core papers, this was an inconsistent area. In Paper A, questions related to infection control and sterilisation were often answered with general statements or suggestions for unrelated actions. Students struggled to link their knowledge to the specific scenario presented, missing opportunities to tailor the response and maximise marks. In Paper B, while students often understood the scientific principles, they struggled to apply this information clearly to healthcare contexts, particularly in areas like MRI safety, chemical reactivity, or interpreting diagnostic processes. Responses were often too vague or generic to meet the requirements of AO2. Implications for teaching. Build in scenario-based questions regularly. Get students to practice adapting knowledge to different healthcare contexts. Use the "what is this question really asking" strategy. Teach students to underline the focus and scenario in every question. Promote role-based scenarios. For example, what would a lab technician do here, to help them bridge theory and practice. Encourage structured practice using real NHS examples or case studies to bring theory to life. AO3 remains the biggest challenge across both papers. Many students defaulted to description rather than evaluation. In Paper A, extended response questions around waste management policy or pharmacy service quality were often answered by repeating the scenario or listing suggestions, without weighing the pros and cons or considering implications, key elements of AO3. In paper B, questions that required scientific evaluations, such as assessing food preservation, investigations, or gas chromatography validity, were often approached factually, without critique or conclusions. Students could describe the science, but didn't link back to the scenario to form a judgment. Implications for teaching. Model Band 3 writing with annotated examples showing how to structure evaluations using different scaffolding techniques or point judgment impact. Use sentence starters such as "this is effective because" or "one limitation is" to get students used to evaluative phrasing. Run compare the response tasks where students judge two answers and explain which is stronger and why. Encourage peer reviews of ERQs to help students recognize the difference between explanation and evaluation. As we close this session, there are several key takeaways to keep in mind when planning delivery, revision, and assessment preparation for the core component. Firstly, the strong performance in maths question is a clear positive. Students are increasing confidence with calculations, units, and formulas, and this is something to celebrate and continue embedding. However, contextual learning remains a priority. AO2 responses show students often knew the content but failed to apply it accurately to the scenario. We need to keep giving them opportunities to practice a skill through structured real-life tasks. Improving AO3 is where we can have the biggest impact. Evaluation needs to be taught explicitly, not just hoped for. Students benefit from modelling, sentence structures, and scaffolded reasoning to build evaluation depth. Also, science-heavy content, particularly in chemistry and physics, should be reinforced through visual tools, interactive learning, and case study application. Diagrams, simulations, and scenario walkthroughs can all enhance understanding. Finally, identify and address common misconceptions early. Use retrieval tasks and informal quizzes to catch misunderstandings about radiation, infection control, or legislation before they become ingrained. By taking these insights forward, we can support our learners not just to pass the core exams, but to do so with confidence and depth. Please take a few moments to complete this feedback form. Your insights are very valuable. Thank you for watching.